extremely sorry for the delay today. As you can see, we're trying out something new to improve your experience. So obviously we had some teething problems, but I presume it is okay now, and all of you would like the new improved version much better. This is what I feel. So just let me know what is your thought about what you are getting now, so that we know how our attempt has worked out. I'm very sorry for the delay that we have faced today, but let's hope that that's the end of it. That's the end of it now, and we are not going to face the same issue again. Okay, great. What happened? Okay. So also we are starting some extra uh, step today. That is, I'll give you the time to ask your questions at the end. So you can hold your questions, or you can just post your questions, but I'll take them up at the end of one session. So I'll keep finishing the sessions one by one, and then I'll take your questions. So I hope that will be okay with everyone. You should not have much problem with that. And with that, let us uh, let us start. Okay, just let me see. Where are we? Does it come on the screen? Does it come on the screen? Does this come on the screen? This one is come on the screen. Great, great. Okay. All right. Welcome everyone. And today we are starting with the topic of molecular biology. I told you yesterday, we are going to be starting from the topic of molecular biology. Just let me know if you have the audio clear, the video clear, and you can see the pad. If you can see the pad, uh, we will improve it a little bit tomorrow. Today we have tried to make it as good as possible in the short time that I had today, but after the class today I'll try to perfect it, and so that tomorrow you get slightly better output than what we are getting today. Okay, are you able to see the audio? Are you able to see the audio? And are you able to get the audio? I'm sorry, and the video? Okay, great. So let's start with the molecular biology section. We are starting with the molecular biology. So in the molecular biology section, broadly we'll be talking about two things. First, we'll talk about the properties. The properties will cover the various sections, like the nucleotides and the nucleic acids. All right, the first thing we'll do is the properties of nucleotides and the nucleic acids. Second thing that we'll talk about is the biosynthesis. So first we talk about the properties, and then we talk about the biosynthesis, or rather I would say biosynthesis and metabolism. Biosynthesis and metabolism, because for purines and pyrimidines we'll also be talking about degradation. So biosynthesis and metabolism, here we'll talk about the biosynthesis of the purines and pyrimidines. After that we'll talk about the DNA, then we'll talk about RNA, and then we'll talk about the protein, how the protein synthesis is occurring. Along with that, we'll also be covering various associated regulatory mechanism or inhibitors of the pathways, and if time permits, accordingly we'll talk a little bit about the lac operon. We'll talk a little bit about the lac operon. Lac operon is being frequently asked in your exam, and there is a variant of the lac operon which is used in genetic engineering. So I'll be mentioning that also. Okay, so I'll be mentioning that also. So these are the broad headings that we are going to discuss. First, the properties of the nucleotides, and then we'll talk about the biosynthesis and the metabolism of the nucleotides and the nucleic acids. So let's first start with the properties. Let's first start with the properties. Okay, so when this one comes here, not able to see it. Okay, I hope it is coming now. Is it still stuck? Is it still stuck? Yeah, it's still stuck. Why is it stuck? Hmm, something like that. Come on. Okay. Don't worry, I've not started anything new, so shouldn't be a problem. Okay, shouldn't be a problem because I haven't started anything new. No, I don't want. Yeah, great. So don't worry, I haven't started anything new, so shouldn't be an issue. So we are just going to now start with the properties of the nucleotides. So starting off with the nucleotides. So when I say nucleotides, I presume that all of you know that nucleotides themselves are made up of three parts. In the center, we have what is known as the pentose sugar. In the center, we have the pentose sugar, right? To this pentose sugar, there is attachment of the nitrogenous base, and on the other side, there is attachment of the phosphate. So together they make up the nucleotides. In the nucleotides, we have the pentose sugar, we have the nitrogenous base, and we have the phosphate. Sometimes we can only have the pentose sugar and the nitrogenous base when we call it the nucleoside. So we'll come back to this structure, but first let us talk about the nitrogenous base separately. Then we talk about the pentose sugar a little bit, and then we'll come back to this structure that I have shown you for the nucleotides. So starting off from the primary building block, and that is the nitrogenous bases. So we are beginning the story from the nitrogenous bases. So briefly about the nitrogenous bases, what exactly do you mean when you say the nitrogenous bases? So nitrogenous bases are basically heterocyclic compounds. What do you mean by heterocyclic compounds? Number one, they are. Don't worry, I am continuously looking at the video feed, and when it gets stuck, you will not miss out anything because I am stopping at that moment. So you are not going to lose anything if there is a lag in the video. and I've opened a separate widget showing me in the YouTube feed that you are getting, and I'll be able to modulate the output accordingly. I don't know why it is happening, because today we have a very good internet speed at my end, almost 4 Mbps is there, and there is no reason for the video to get stuck. But let's see what is happening. Okay, so the heterocyclic compounds. When we say heterocyclic compounds, basically two things you have to keep in mind. Number one, these are ring structures. I'm sorry, these are ring structures. That is the cyclic compounds. They are ring structures. That is, they are cyclic compounds. And number two, they have atoms other than carbon within the ring. That is why the term heterocyclic is used. The term heterocyclic is used because they have atoms other than carbon in the ring. In this case, they contain nitrogen. So they are nitrogen containing ring compounds of carbon. They are nitrogen containing ring compounds of carbon. So that is one part. They are heterocyclic compounds. Now, whenever we have ring structures, you had seen when we are talking about the carbohydrates also, they form a plane. Some parts is above the plane of the ring, some are below the plane of the ring. So we call that property the planar character. So natural bases are heterocyclic compounds. They have planar character, but most importantly, they show the property of tautomerism. They show the property of tautomerism. When I say tautomerism, it means that there is interchange of functional group due to migration of double bonds. This means that there is slight shift, or you can say continuous change in the property of the ring structure, because the functional group is continuously shifting. The functional group is continuously shifting. I'll show you the example. So this is a structure like this. We have a double bond, and let's say there is attachment of a hydroxyl group. There is attachment of the hydroxyl group. As you know from your studies of 11th and 12th, the oxygen nucleus is closer to the outer rings of electron, and it has a tendency to pull the electrons. So what happens, this ring can migrate, the double bond will migrate closer to the oxygen, and there can be migration of the double bond. There can be migration of the double bond, whereby the hydroxyl group will now become the keto group. So this is the interchange of functional group, the hydroxyl group to keto group and the keto group to hydroxyl group. I can see that there is some issue with the video, but it is totally beyond my understanding, because we have very good internet speed today at my end. I don't know why it is getting stuck. There should be no reason for the video to get stuck. We are getting very good internet speed at my end. There are zero drop frames. We have sufficient buffer to make up for the delay. Ah, mm. Okay, so tautomerism, that is interchange of the functional group due to migration of the double bonds, is a very important property of the nitrogenous bases. And as you know, the nitrogenous bases are of two broad types. we have the purines, and we have the pyrimidines. The purines and the pyrimidines. So these are the two main subgroups within the alternative bases, the purines and the pyrimidines. As you know, the some of the important purines are the adenine, guanine. In addition to this, we have names like hypoxanthine and xanthine. Whereas in the pyrimidines, we have cytosine, uracil, and thymine. All right. Among the purines, all of them are commonly found in the nucleotides, whether it is the DNA, nucleic acid, whether it is the DNA or the RNA. Very frequently, you'll also find the hypoxanthine in the RNA, but these two are almost always in both the DNA and the RNA. Whereas coming to the pyrimidines, the cytosine is found in both